Hey there, science fans! Ever wondered how your computer can run multiple programs at once? Like, you could be listening to groovy tunes while writing an email and also downloading a super cool science documentary, all at the same time? This, my friends, is the magic of multitasking, and it's all thanks to something called processes. You see, a computer might seem like a super smart machine, but at its core, it's just following a set of instructions, one step at a time. To juggle multiple tasks, the computer uses processes. Think of processes like individual workers in a busy factory. Each worker has a specific job to do and they work independently, but together, they keep the entire factory running smoothly. That's what processes do for your computer. They are the fundamental units that allow your computer to perform many tasks seemingly simultaneously. Pretty neat, right? Let's dive in and learn more about these amazing processes. Now you might be thinking, Bill, is a process the same thing as a program? Great question. A program is like a recipe in a cookbook. It's a set of instructions written in a language your computer understands. A process, on the other hand, is what happens when you take that recipe and start cooking. It's the active execution of those instructions. Imagine you have a program for baking a cake. The program is just the list of ingredients and steps. But when you actually start mixing ingredients, preheating the oven and pouring batter, that's a process in action. A process isn't just the instructions, it includes the current status of all those ingredients, how hot the oven is, and how much time is left. It's everything involved in turning those instructions into a delicious cake. Similarly, a computer process involves the program code, the data it's working with, and its current activity. Just like a cake goes through different stages in the oven, a process goes through different stages in the operating system. This journey, from creation to completion, is called the process lifecycle. 1. Imagine a brand new recipe you've never tried before, it's just sitting in the cookbook. That's a process in the new state, it's been created but hasn't started running yet. 2. Ready. You've decided to make the cake. You gather your ingredients and preheat the oven. Now, the recipe is ready to go. Similarly, a process in the ready state is all set to run. It's just waiting for the CPU, which is like the chef of your computer, to give it some attention. 3. Running. The CPU is now actively following the recipe, mixing, baking, and keeping an eye on the timer. This is the running state. The process is actively being executed by the CPU. 4. Waiting. You realize you're out of milk. The cake baking has to pause until you get more. A process can also enter the waiting state if it needs something like data from a hard drive or input from the user. 5. Terminated. Voila! The cake is baked, the timer has gone off, and you're ready to enjoy. Similarly, a process enters the terminated state when it has finished its task or is no longer needed. This cycle of states ensures that the operating system can manage multiple processes efficiently, giving each one a chance to run and complete its task. Just like a chef needs tools, a process needs resources. Think of these resources as a stack of plates. You can only add or remove plates from the top. The stack stores temporary data and tracks execution. The heap is like a jumbled drawer for data. The program counter is like a bookmark. The process control block, PCB, manages resources. Think of the PCB as the process's ID card. Processes can work together like chefs in a kitchen. They communicate through shared memory or message passing. Scheduling algorithms decide CPU usage. These processes make your computer multitask efficiently. Keep those processes running, science fans.